4, and you want to divide it into 4 equal piles, how many is going to be in each pile? 1. That's what 4 divided by 4 means. Is that cool? If you take 4 apples and you divide it into 4 piles, what does that equal? 1 what?
One apple per pile.
One apple.
One apple. Oh, wow.
Oh my God.
One apple pie.
1 apple pie. Right? 1 apple per pie. Is that okay? You guys get that? So that makes a ton of sense to me. Like visually it makes sense, conceptually it makes sense, I'm good with that. But what if I take 4 apples and I divide it into 4 apples?
You have one big apple.
Yeah, really,
One apple per
You
apple.
get one
really.
giant
I'll put it
apple.
on the Empire
You
State.
get New York City.
If I have 4 apples, you were okay with this, 4 apples divided by 4 piles is 1 apple per pile. What's 4 apples divided by 4 apples?
One apple.
One apple per apple.
Yeah. One apple each. One apple per apple.
Well, you
apple.
should have one big apple. So you can work City.
Well, what you end up with here is a weird thing.
Just one.
You end up with just 1. Okay? See, conceptually, this is really hard to understand, because if you have 4 apples, and you want to divide it into groups of 4 apples, how many groups do you have? Just 1 group. But we don't put the group in here. I mean, think about it again. You have 4 apples, how many groups of 4 apples do you have? Just 1 group. But in your math class, they do a silly thing, they're like, oh, well 4 divided by 4, you can cancel and it's 1. And oh, you can apples, you can cancel. It manifests like this. What's x divided by x?
One X,
Well,
one.
depends what X is. One.
It doesn't, I mean, if x is the same thing, this is 4 divided by 4, or apples divided by apples. It just is 1. They somehow magically disappear, and your math teachers say you canceled them out. I don't know what that means, but some stuff magically disappeared. The point of my story is that if you have a number over a number, it divides to 1. If you have apples divided by apples, it divides to 1. If you have x divided by x, it somehow divides to 1. Would you buy that? Okay? How does that manifest over here? Look more closely. What I have here is I have 1 second times 40 centimeters divided by 1 second. What happens? Do you have 1 second divided by 1 second?
They cross out.
Okay? Somehow they magically disappear, and what are you left with?
47.
You're just left with 40 centimeters. Comparing that to this over here, what does 40 centimeters tell you about the car, or what does 40 centimeters tell you about the car?
So far, what?
How far it went, how often?
Every
Every
second.
second.
Every 1 second. What's cool about this is by shading this area, you can actually figure out how far your car went. This is the most interesting thing, because if you look here, if I drop another vertical down and I shade this one, it went another second, and it went another 40 centimeters. Is that okay? Look what happens in the total time. If I come over here and I drop this vertical down, if I shade the whole area, okay, including these guys over here, what is the total area there? Check with your neighbor. What's the total area of that rectangle? Check your neighbor now. What's the total area of that rectangle? Check your neighbor now.
200.
Ben, what is it? How much? What's the total area? Oh, I'm sorry. I didn't mean to get you. Other Ben, what's the total area?
120.
Oh. Yes. Not my question, but yes, you answered. He said, he looked at this one and said, what's the area of this section? I meant the total area. What's the total area?
200.
It is. Because it's 40 tall and 5 wide. What's 40 times 5?
200.
200. What else is 200? What else is 200? It's the change in the position, remember? So here's the moral of the story. Okay? The area on a velocity versus time graph is the change in the position. It basically tells you how far you went. Now, we're going to practice this. I'm giving you an outline of how to do this, so that when you get to it, you're like, oh, is that what he was talking about? But I do fully understand that I'm talking about it, and you're listening, and you're doing a really nice job listening, but you're not getting very much from this. I totally understand. Or you're not going to get anything from it until you actually try to put the pencil to the paper and do it yourself. Does that make sense? Which we are going to do shortly. So, last bit. If I come over here and I look at this, what's the slope of this line? The slope's the velocity, right? So if you look at this, it's 40 centimeters per second, that's the slope, that's the value of the velocity. If you want to figure out how far it goes here, if you want to figure out how far it goes, you can just do the change in the position. And then if you want to figure out how far it goes over here, you do the area. We're going to work with these graphs a little bit. Is that cool? All right. Yesterday I gave you a homework 1 and a homework 2. Bust those bad boys out right now.
I've never really been like someone to use colors.
Isn't it fun though?
It is, but I don't know.
I will tell you, when I was in college, I had lots of science classes when I was in college. And the teachers, they would draw, I mean, this is a big lecture hall. So they're sitting on a stage with an old school overhead projector. And they're doing the thing where they're like sitting on a stool, writing on the overhead projector, and this projector is projecting onto a huge screen. Because there's like 200 people in the lecture hall, right? But they're writing with different colors. They use red, blue, black, and green. So we were all armed with those pens that have the red, blue, black, and green. And when the professor would switch colors, you'd hear literally 200 people go click, 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 and it was like this massive click, right? Because we all would like switch to the color, because we were dutifully taking notes. So I like the color. One of the things that I'm going to do is, when I draw the axes here, I'm always going to make my axes black. My position lines are always going to be red. My axes are black. My velocity lines are always going to be green. And then later on, we're going to study acceleration. My acceleration lines are going to be blue. We're always going to put the colors on, so you're always keyed in to the same color. You guys with me on that? Position lines are always going to be red. Velocity lines are always going to be green, and acceleration lines are always going to be blue. Is that cool? All right. You got your homework 1 and homework 2s out?